Alright, in the last video, we understood about uniform probability distribution. And in this video, we are going to understand about normal probability distribution. So in the case of uniformly distributed probability, we used to make a rectangle on the axis. But in the case of normal distribution, we are going to visualize the probability with the help of a bell-shaped curve. Okay, this is our bell-shaped curve, and on the x-axis is our z-score. So x-axis has our z-score. The midpoint is 0, signifies the z-score 0. On the right side, the right direction or the right portion is the positive one and the left portion is negative one. Just like an integer which starts like this: -2, -1, 0, +1, +2. Similarly, z-scores also starts like this: -2, here -1, the middle is 0, here +1, +2, and so on. Okay, now we knew that in the case of uniformly distribution probability, the whole portion inside this box, inside this rectangle, is our area, which is always 1. The whole area of the box of the rectangle is 1. Similarly, in the case of normal probability distribution, the whole portion of the bell curve, the whole portion inside the bell curve is 1. The area of the bell-shaped curve, the portion inside the bell-shaped curve, is always going to be 1. I hope you got it. Now, if the whole area is 1, let me clear this. So the half portion is going to be 0.5, and this portion is also going to be 0.5. Okay, so the concept of normal probability distribution is really important, because when you will compute any random z-score, you will have to find out the probability with the help of this chart. So this is our standard normal cumulative probabilities, alright, which is given in the diagram. Starts from -3.4 and ends on +3.4. So let's understand what are these and how to identify the z-score and how to identify the probability with the help of a z-score. So let me make the normal probability distribution diagram. This is our bell curve. And on the x-axis lies the z-score. For example, our z-score has the value of 1.00, right, which is positive. So here you can see positive Z, which is 1.0. We need ZS as 1.00. So these are the fraction values till 0.09, starting from 0.00 to 0.09. So we have to calculate the probability of Z score, which is 1.00. This is 1 point, this is 00. So the probability for Z score 1.00 is going to be 0.8413. Alright, I hope you must have understood this. So let's visualize this with the help of normal probability distribution diagram. Let's make the bell curve, and our Z score is 1.00. So our probability will be like this much portion, which is 0.8413. Alright, let's take some other example. Let's say our Z score is negative 1.00. So how are we gonna visualize this? Negative 1 lies over here, this is 0, and positive 1 lies over here. So what will be the probability of this much portion? We can identify this with the help of the Z table. So minus 1.00, the probability for Z score minus 1.00 is going to be 0.1587. So this much portion is 0.1587. I hope you have understood this. Alright. Okay. So let's compute the normal probabilities. This is our bell-shaped curve. Now, let's understand mean and standard deviation in the case of normal probability distribution. So, in the case of normal probability distribution, the mean is the midpoint of this bell-shaped curve, which lies in the middle of this bell-shaped curve. And the standard deviation is denoted in the symbol sigma, which is written on the right side, top of the right side of the bell-shaped curve. Alright. The formula to calculate Z score is x minus mu divided by sigma. This is a very simple formula and easy to remember. Okay. Now, why we are calculating Z scores? The sole purpose to calculate this Z score is to identify the probabilities in a particular situation which will be given to us. So let's take an example, a situation of Gerer Tire Company problem. In this situation, this is a tire company which is giving us a situation. Suppose the Gerer Tire Company just developed a new steel belted radial tire that will be sold through a national chain of discount stores. Because the tire is a new product, Gerer's managers believe that the kilometers guarantee offered with the tire will be in an important factor in the acceptance of the product. Before finalizing the kilometers guarantee policy, Greer's managers want probability information about the number of kilometers tires will last. In simple words, suppose let's say that you are a manager in a tire company and you want to launch a new technology of a tire. So you will have to test and identify that how long the tire will last, how much kilometers it will last with the help of a probability. Now, in this case, the Greer's engineering group estimates that the mean number of kilometers the tire will last is 36,500 kilometers. So in the case of normal probability distribution, mean is always denoted by mu, symbol mu, and in this case the mu is 36,500. Okay, and that the standard deviation is sigma, which is equals to 5,000. Standard deviation sigma is 5,000. So mu is our kilometers. This is the average kilometers that the tires will last, is quoted by the engineers who are working in the tire company. In addition, the data collected indicate a normal distribution is a reasonable assumption. What percentage of the tires can be expected to last more than 40,000 kilometers? They want to know that how much will the tires will last more than 40,000 kilometers. So this is going to be our probability equation. They want to know that the random variable x, which is the percentage, how much of the percentage which is going to be more than 40,000 kilometers that the tires will last. This is we have to calculate right now with the help of normal probability distribution curve. So let's understand this. This is our bell-shaped curve, normal probability distribution. As I told you previously, the mean lies in the middle, which is mu, denoted by mu, which is our 36,500 in this case, and the situation has been given to us as 40,000 kilometers. Okay, they are asking us this much portion, more than 40,000 kilometers. What is the area of this portion? Area is nothing but probability. To calculate the area, we have a formula of z-score to identify the probability. We identify it with the help of a z-score, which is going to be x minus mu upon sigma. In this case, our x is going to be 40,000. Okay, as per the situation. So 40,000 minus 36,500 divided by 5,000, which comes around z 0.70. Okay, so this is our positive z-score, and we also know that the 40,000 side lies on the positive side. To identify the area, we'll have to check the z-score table so that we will be able to understand it. So z-score in this case is 0.70, and which is giving us the probability as 0.7580. Alright, on the positive side. So the probability of x, which is greater than 40,000, is which comes around 0.7580. Okay. I hope you got an understanding, clear understanding. So the value for z, which is 0.70, is comes around 0.7580. Okay, meaning that if we visualize this z score 0 and 0.70 lies somewhere here. So the probability shows us this much portion, meaning that the probability for z score 0.70 is 0.7580 is this much portion. But in our scenario, in our case, we have to determine the probability of this portion. This portion. We want this portion, area of this portion. So we know that area of normal distribution curve is 1, and if we want this much portion, so the probability for x, which is greater than 40,000, going to be 1 minus 0.7580. We will subtract this much portion from the area 1. We will get the probability as 0.2420. Okay, in conclusion, the probability of tires which will last more than 40,000 kilometers is going to be 24.20%. This percentage of tires will result in lasting more than 40,000 kilometers. Alright, I hope you must have got this.